we're going to take a look at the biconditional. The biconditional means I have a conditional that works in two ways. We're going to use this double-headed arrow to represent the biconditional. And what the biconditional really means is that P implies Q and Q implies P. So using this double-headed arrow makes the statement a lot shorter to write. And we're going to read this double-headed arrow, P double-headed arrow Q, as P if and only if Q. So let's take an example. A single album reaches gold certification if and only if it sells 500,000 units. This statement tells us that if a single album is gold, then we know it has sold 500,000 units. That's P implies Q. It also says if a single sells more than 500,000 units, then it is gold certified. So that's our backwards, and I guess I should have wrote that in there. So let's write it really quickly. That says Q implies P. So you can see we have both directions. We understand what this means. So how is this different from the conditional? Well, the conditional only works in one direction. Think about our statement. If you're a mother, then you have a child. Does that mean if you have a child, then you're a mother? Well, of course not. You could be a father and have a child. So everything that works in one direction doesn't immediately work in the second direction. So the biconditional is a really strong statement that gives us a lot of information about the relationship between statements being connected. So let's look at the truth table for the biconditional. So our normal P and Q, but now this biconditional, which says P implies Q and Q implies P, luckily is really easy. It's really just where it matches. So when I have two truths, it's true. True false is going to be false. Remember, true implies false is false. I already know I'm done. But then this false true, when I went in the other direction, true false would be false. And then false false is true. So don't overthink it. The rule for the biconditional is matching is true. And you can see that right here. True true is true. False false is true. And then when they don't match, it's false. So let's make it bigger. Let's make a truth table for P and Q if and only if, not P or Q. So I set out our columns. We know we have to have the basics P and Q. I have a negation of P, so I have a column for that. I have two sets of parentheses, so I need to do each one of those in a column. So I have one for P and Q. I have one for not P or Q. And then the last column is always the whole thing put together. So let's fill in the basics. Okay. So here's our P, true, true, false, false. Q is not right. Let's see here. I fixed it. Sorry about that. Is true, false, true, false. And then not P, false, false, true, true. And then P and Q is where we start putting them together. So here, putting it together, P and Q. True, true is true. True, false is false. False, true is false. False, false is also false. If I now look at not P or Q, so here's not P or Q. I only need one true when I'm looking at or. So this is true, false, true, true again. Okay. The final one where I'm comparing these two columns, I'm just looking for matching. So true, true is true, false, false is true, false, true is false, false, true is false. All right, so let's do another one. Let's make this bigger. Let's add R in. So this time I'm going to do P if and only if Q or R. Okay. Again, my layout. I have P, I have Q, I have R. Q or R need to go together before I can do the whole statement. The basics. So remember, P goes in 4s, Q goes in 2s, R goes in 1s. Okay. Then I can put together Q or R. Thinking or means I need one true. So I have true, true, true. So I can see the three truths, make these three truths, and then false. And then once more, true, 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 and then false. So you'll see that here. Okay. Then looking at the last column, I'm taking the first column P with the column we just did of Q or R, and I'm looking for matching. So true, true is true, true, true is true, true, true is true. True, false is false. False, true is false. False, true, false. False, true, false. But then the last one, false, false is true. So lots of trues and false. Just keep together that idea of or means I need one true, double conditional. This biconditional means I need them to match, and I'll add and in here later so we can talk about that as well. So I want you to try. I'll keep it pretty simple. I have P if and only if, not Q. Try to set that up, give yourself a few seconds, and then come back to do it, or to check it, I mean. All right, so here's what I got. Basics, true, true, false, false, true, false, true, false. And then the not Q was false, true, false, true. I'm comparing the first and the third columns, and I just look, do they match? So true, false doesn't match, that's false. True, true matches, that's true. False, false matches, that's true. And then false, true will be false. So you can see, when they match, I say true. When they don't match, I say false. Let's try it again. Just make it a little bigger. This time I want you to do P or Q if and only if, not R. Again, I want you to try this. So pause the video, work this out, make sure you have all the columns right, and then check and see how your truth values did. Alrighty, so I always want to show you first, here's my layout, P, Q, R, not R, P or Q together, and then the whole thing at the end. Okay, so I threw in the basics. 4 trues, 4 falses, 2 true, 2 false, true, false all the way down, and then I flipped over that R to become not R. Right, P or Q, I'm looking at the first 2 columns, and I'm just looking for a true. So I have true, 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 true. Okay, 6 trues in a row between the 2 columns says I have 6 trues over here, and then the last 2 are false. Luckily, these are side by side, so now I'm just looking, do they match? So this is false, true, false, true, false, true, true again, and then false. So every time I was looking, do the 2 statements match when I have the biconditional? Okay. Again, let's go back to truth values versus truth tables. And truth values just says, hey, when we know the value of a statement, we don't have to go through this whole process of a truth table. So here I gave you 4 equals 3 plus 1 if and only if 5 minus 2 equals 6. Okay. Sometimes it sounds kind of crazy, so just go back to basics here. 4 equals 3 plus 1. I know that's true. 5 minus 2 is 6 is false. So you see that's what I wrote in here. First statement is true. Second statement is false. These don't match, so my overall statement is false. Next one, 0 is positive if and only if pi is negative. So same deal. I want to go back and substitute what do I know. 0 is positive is a false statement. Pi is negative is also a false statement. But these 2 match. So overall, my statement is true. Logic doesn't always mean it makes sense, right? That seems like a very weird statement to say. Maybe it's hard to understand that it's true overall. Stick to the truth values. That will really help you. So write down what the truth value is, think about how the connectives work, and then just put it all together. All right. So here's 2 for you to try. I want you, oops. I think I might have erased too much there, sorry. I want you to try to ignore the answer because I clicked it too much. The 4 equals 2 plus 2, or 5 minus 1 equals 3, if and only if 8 divided by 2 is 4, and then 8 is less than 2, if and only if 7 is greater than 2, and 10 is less than 1. All right. Here I have a lot going on. 4 equals 2 plus 2 is true. 5 minus 1 is 3 is false. So I'm not trying to answer it all at once. I'm just substituting in the values I know. 8 divided by 2 is 4. That's true also. So see that I kind of left the or in there. I just put the arrow, double arrow in for if and only if, but I'm not trying to do more than one step at a time. True or false is true. True if and only if true is true. So that one, my overall truth value is true. Same thing here. 8 is less than 2. If and only if 7 is greater than 2 and 10 is less than 1. So we really want to start with just what do we know? 8 is less than 2? No. So I write false. 7 is greater than 2. That's true. 10 is less than 1. That's false. Here I want to first do true and false is false. False if and only if false. That actually, let's mark that out because I think I copy pasted there. That should be a true, so I want to make sure we get that correct. So this answer is true. All right, that's the end of this.